Hi, my name is Tim Middleton. I'm a software engineer with the Coherence development team here at Oracle. Welcome to this screencast which covers an overview of Federation using the Coherence Operator version 2. In this video, we will provide a short overview of the Coherence Operator, outline its support for Federation, as well as show you a demonstration of the features. What is the Coherence Operator? Firstly, what is an operator? An application-specific controller that extends the Kubernetes API to create, configure, and manage instances of complex applications. The Coherence operator is an operator that allows users to create, configure, and manage coherence clusters within a Kubernetes environment. So what does the operator provide? The ability to easily deploy, run, and manage coherence within a Kubernetes environment. Integrates with common components used in Kubernetes such as Elasticsearch, Fluentd, and Kibana for log capture and analysis, and Prometheus and Grafana for metrics and monitoring. Defines the configuration of coherence clusters via the custom resource definitions or CRDs. Allows you to override and customize your coherence deployments as well as declare startup parameters for those deployments. Allows safe scaling out or in via Kubernetes with no data loss. Ensures coherence is aware of Kubernetes zone information to provide coherence cluster high availability. Allows you to use persistent volume claims to support active persistence. Provides application code deployment via sidecar container as well as definition of coherence application roles via the coherence cluster resource definitions. For more information on the Coherence Operator version 2, please see the Coherence Operator 2 overview and demo screencast. The Coherence Federated Caching feature is used to link multiple clusters so that cache data is automatically synchronized between these clusters. Typically, these clusters are geographically dispersed and can provide redundancy, off-site backup, and multiple points of access for application users in different locations. The Coherence operator provides full support for federation between coherence clusters in separate Kubernetes clusters when using Coherence version 12.2.133 and above. Metrics are also captured and can be viewed within Grafana on specialized federation dashboards. In this demonstration, we will use the Coherence demonstration application to showcase the Coherence Operator 2 federation support. We'll show installing the Coherence operator, building and installing the Coherence demonstration application, installing the primary and secondary clusters and enabling federation, and viewing metrics and log files via Grafana and Kibana. For this demonstration, we are showing federation between coherence clusters within a Kubernetes cluster, but the concept is the same and can be easily tweaked to federate between separate Kubernetes clusters. Firstly, we will install the Coherence operator into the namespace Coherence Demo NS and enable Prometheus and Grafana integration, as well as set log capture to true. Let's list the installed releases and the pods that make up the release. We can see that we have the operator, we have Grafana and Prometheus, as well as Elasticsearch and Kibana. We'll now port forward the Kibana and Grafana ports. As we mentioned, we are using the Coherence demo for this screencast. This application consists of a storage tier to hold cache data, plus a storage disabled tier that serves application code and REST endpoints. We have already run the Maven clean build to build the codebase and create a Docker image which contains all the required application artifacts such as cache config, override files, and pofconfig. This Docker image will be specified when we install the cluster. If we list the build directory, we can see the files that are copied into the Docker image. In the lib directory, there is application code. In the conf directory, the cache configuration and override files. Next, we will install the two clusters, primary cluster and secondary cluster, which are both configured with federation. Let's take a look at the cache configuration and operational override for the clusters. cache configuration is a standard federated scheme where we are setting the topology to active, which is defined in the override file. We will also set the port for federation to be 40,000, which we'll reference in the YAML install. The operational override file defines the active-active topology and the cluster participants. The property values will be overridden by the YAML file at install. Next, we'll inspect the YAML for the primary cluster. The cluster name is primary cluster. We've enabled metrics and also a federation port. We have the cache config specified. We have the image we've just built specified. And we have two roles, a storage and HTTP role. The key point to note is that the argument for primary cluster host points to primary cluster WKA, which is the DNS address of a service within the Kubernetes cluster, which maps to all primary cluster pods. This is also set up similarly for cluster 2. As mentioned before, a typical federation scenario would normally be between two different Kubernetes clusters. In this case, we would create a service object to expose cluster member federation port as an external IP address. Please refer to the Kubernetes documentation on how this can be achieved. Let's now install the primary cluster. Let's take a look at the pods. See, we've got primary cluster HTTP and 3 storage. If we look at the services, we can see the primary cluster WKA here. Next, we'll install the secondary cluster. The configuration is the same as the primary cluster except the different cluster name. Let's list the pods. Since we have enabled log capture, we can see that we have 2 containers per pod. We'll need to wait for them to be ready. We can see now that all pods are ready. So next we will port forward the application HTTP port for each of the clusters. So primary cluster on port 8080 and secondary cluster on port 8090. Next we will open both of the application URLs. The Coherence demo application is a mock trading application which holds positions across a number of symbols. There are 100,000 initial trades loaded into the primary cluster. Note that the secondary cluster has no data as federation has not yet started. There are also aggregations running continuously across the data with times displayed on the right. Also, we can see the data distribution amongst the members and the member details below. Now that we have both applications running, let's start federation on the primary cluster. You can see that the secondary cluster has the same number of positions as the primary cluster. If we enable real-time updates, we can see that the data is sent across to the secondary cluster. We will now open the main Grafana dashboard that shows metrics from the primary and secondary cluster. We can see from the drop-down that we can select either of the clusters. The Coherence dashboard main provides an overview of the Coherence cluster with all relevant details. Please see the Coherence Operator introduction and demo screencast for more information on the Grafana dashboards. We will select the Federation Summary dashboard on the right. This dashboard gives us an overview of federation within the selected clusters, including destinations that this cluster is replicating to, and origins that are replicating to this cluster. We can see at the moment there are only destinations as the secondary cluster has not sent any data to the primary cluster as yet. By selecting the Federated Cache service, we can see federation details about this service and we can select the different destinations if there are more than one. Now let's add some data into the secondary cluster, which will be replicated to the primary cluster as they set up as active-active. Once we add 20,000 trades into the secondary cluster, we will see this replicate to the primary cluster. After a short delay, we will see the Grafana dashboard update with the origin metrics. Next, we will open Kibana and view the logs captured from the clusters. We'll do this via the All Messages dashboard. We can see that both clusters are available for selection as well as all the hosts. So if we select primary cluster, this will just show the hosts from the primary cluster. And we can also drill down into message levels as well, or threads. As well as visualizations, Kibana also contains preloaded searches for various types of messages. We can use the Discover tab to search for Federation-related messages. Let's select Execute Action, which will show us any messages where action has been executed on a participant. This concludes the demonstration. For more information on the Coherence Operator, please visit github.com/oracle/Coherence Operator. For documentation, please see the link at the top of the GitHub page. For more information on the Coherence demo and other open source projects, please visit the Coherence community at coherence.oracle.com. Feel free to join our Coherence and Operator Slack channels. Thank you for your time.